everyone. My name is Catherine Kiarie from School of Computing and Informatics. I will be taking you through a unit known as Computer Networks, BIT2119. Welcome. So, let's have our lesson 1. And in our lesson 1, we are going to look at Introduction to Networks. So, let's have our lesson 1 objectives. And in our lesson 1 objectives, by the end of this chapter 1, the student should be able to accomplish the following 5 tasks. The first one, the student should be able to explain the meaning of the different terms used in networking. The other thing, the student needs to be able to understand data flow in a computer system. The other thing, the student needs to be able to explain the basic components of a network. And the other thing, of course, the student needs to be able to explain different types of networks, such as local area networks, metropolitan area network, and wide area network. And the fifth task that the student should be able to accomplish is to describe the benefits of establishing a computer network. So let's get started to Introduction to Networks. And of course, in Introduction to Networks, we need just to have an overview of what are these computer networks and why do we need it, or why are they so important in different organizations or business setups. So you can say that in its most basic form, a network is 2 or more computer systems which are linked together by some form of transmission medium that enable them to share information. So you can see the key thing is being able to share resources or rather to share information. A network will provide services to its users, and these services can include access to files. You can be able to access folders, network printing, and other database applications. We still go to the introduction bit of networks, and we can say that computer networks make it possible for several people to be able to share data and different peripherals, and of course things like printers, disk drives. All these can be shared simultaneously. The connection can be via copper wire. You can do connection through fiber optics, microwaves, infrared, and communication satellites. We know that computer networks comes in different shapes, they come in different sizes, and of course they come with different capabilities and functionalities. And of course they're usually connected together to make larger networks, with the internet being the most well-known example of network of networks. Or rather, the greatest computer network we have is the internet. So we now go to definition of terms, so that we can look at the common terms that we'll be encountering when you're talking about computer networks. And of course, the first key term we need to know how to define is what is a computer network. And of course, there are many ways that you can define a computer network, but at a very basic level of definition, we can say that it is a group of computers interconnected together so that they can be able to share resources. And we have seen there are so many resources that can be shared, like printers, disk drives, and the like. The other key definition you need to be able to know is what is a message. Now the information that is to be communicated is what we call a message. And of course, popular forms of information, these information can be in form of text, in form of numbers, in form of pictures, audio, video, and the like. The other term we need to be able to define when we are talking about computer networks is the sender. So in this case, the sender is the device that sends the data message. So in this case, the sender can be a computer, it can even be a telephone, it can be a workstation, a video camera, and so on. The other key term is a receiver, because where there is a sender, of course there is a receiver. So in this case, the receiver is the device that is going to receive the message. So in this case, again, the receiver can be a computer, it can be a workstation, it can be a telephone, a television, and so on. The other key term we need to be able to define is the transmission medium, or the path that you are going to use to transmit data. So in short, we can say a transmission medium is the physical path by which a message travels from the sender to the receiver. And of course, we have talked about the sender and the receiver. So the communication path, or the link between the sender and the receiver, is what we are calling transmission medium. And of course, we'll be looking at transmission medium as we go on. But of course, when you're looking at transmission medium, it is either wired transmission media, or we have the wireless transmission media, or the guided, or what we call the unguided transmission media, where there is a physical link between the sender and the receiver. So that is a transmission medium. The other term you need to be conversant with when you're talking about computer networks is what is a protocol. So in short, we can say a protocol is a set of rules that govern data communication. So these rules that govern the whole process of communication in a network is what we call protocols. Later on, we'll be talking about network protocols. And of course, it represents an agreement between the communicating devices. So when you don't have a protocol, of course, two devices connected together may not be able to communicate. So protocols are very, very critical, and we'll be talking about them later on. The other term you need to be conversant with is a node. And of course, in this case, a node is any active device on the network. So a node can be a computer, it could be a printer, as long as this device is capable of sending and receiving data that is generated by other nodes on the network. That is what we call a node. The other term that is critical is segment. So what is a segment in the context of computer networks? A segment is any portion of network that is separated by a switch, or even a bridge, or a router from other parts of the network. The other key term you need to know is the backbone. So what is a backbone? So the main cabling of a network that all of the segments connect to is what we call a backbone. So the main segment where all of the other segments connect to. And of course, because it is the backbone is capable of carrying more information than the individual segments. So now that we have seen key terms that we'll be encountering as we talk about computer networks, let's see the data flow in a computer system. And of course, because we are talking about interconnection of two or more computers for purposes of sharing resources. So let's look at data flow in a computer system. So communication between two devices can be simplex, or even half duplex, or what we call full duplex. And of course, we have a diagram here showing the direction of data, whether it is a simplex, half duplex, or full duplex. And you can see the diagram here is depicting how is the direction of data. Is it flowing maybe one at a time? Is it flowing in both directions one at a time, or is it flowing in both directions simultaneously? So that is what we call data flow in a computer system. So we are saying, let's just explain the three data flow in a computer system. What we are calling here the simplex, as depicted in this diagram. What we are calling the half duplex in diagram B, and the full duplex in the image C. So simplex, or rather what we call the simplex mode, it simply means communication can happen in unidirectional manner. That is one way at a time. So when you talk about two devices that are linked together, we talk about only one of the two devices on a link can be able to transmit the other one can only receive. And we have examples there. We have the full half duplex. Communication can happen both ways, but of course not at the same time. So we say half duplex mode. Each station can both transmit and receive, but not at the same time. And of course, when one device is sending, the other one can only receive, like what you have with the walkie-talkies and the like. The other one is full duplex. This is communication can happen both ways simultaneously. So both stations can transmit and receive simultaneously, as has been depicted there before in the diagram. And of course, when two people are communicating by a telephone line, that both can talk and listen at the same time. So that is what we call full duplex. So now we can go on and look at basic components of a network. So we say that, yes, of course, network comes in different sizes, they come in different shapes, they come with different functionalities and capabilities. But of course, even if we have all these, of course, there are quite a number of components that are important, or other components that make up a network. So let's look at basic components that make up a network. So, and of course, at the very basic, we are saying that despite the variations in size and design of all networks have certain components in common. So, of course, things like the transmission medium, the path through which you will connect the sender and the receiver. You will have a client. Of course, you will have servers among the many other basic components of a network. So, at the very basic, even if you have a network of different size, because there are those that are big, there are those that are small, there are those that cover a small geographical area and the like. Of course, and of course, networks are of different designs. Of course, there are different other things like the physical layout of the network. All these networks differ in all these. But of course, there are quite a number of components that are common in these computer networks. So I want us to look at the basic components that make up a computer network. So the first component is what we call a client, and we need to know what is a client in a computer network. So, and of course, you will realize that when you talk about a client, of course, you will hear a server. So a client is a computer that normally accesses the shared resources on the network. And of course, where there is a client, there will be a server providing the shared resources that are on the network. So we are saying a client, this is a computer that allow a user or even users to log on to the network and be able to take advantage of the resources that are available on the network, or be able to access the shared resources that are available on the network. So a client computer will make a client operating system. So in short, a client computer will have a client operating system, and of course, a server computer will have a server operating system. So we are saying that a client computer will have a client operating system, and of course, the purpose of the client is to get user onto the network. So in short, you're saying the purpose of the client is to enable the user to be able to access or to log on to the network. So therefore, client computers do not necessarily have so much processing power or even storage space or the memory capability that is usually found on a server computer, because the client is not serving up resources. It is only accessing the shared resources on the network. So the other basic component is what we call a server. Now that you have just talked about a client, of course, accessing the shared resources on the network, of course, there is a server that is providing the shared resources that is on the network. So what you are saying is a server is typically a much more powerful computer that runs a network operating system. So this network operating system is what we are calling a server operating system. So the server will provide centralized administration of the network and will be able to serve up resources that are available on the network. So resources such as printers, computers and file. So the administrator of the server is the one who decides who can be able to log in or cannot log on to the network, and which resources the various can access. So the administrator of the network is the one that will do access control and give user rights depending on what a user is supposed to access, or even who is supposed to access this resource or the other. The other component that is make up a network is what we call network interface card or a network adapter. So, of course, the work of a network interface card is to provide a physical link between the computer and the networking medium. So, we are saying attaching a computer to a network will require a physical interface between the computer and the networking medium. So this is what we are calling a network interface card. So let's see the functions that are usually performed by NIC, or what we are calling in short a network interface card. So there are quite a number of functions that are usually performed by the network interface card, and we are saying, of course, it provides a physical link between the computer and the networking medium. So it does establish and manage computer network connection. Another function that is usually performed, or a crucial task that is usually performed by a network interface card, is it translates digital data that is from the source computer into signals appropriate for the networking medium for outgoing messages, and translate from signals into digital computer data for incoming messages. So it does the translation, of course, of signals into a form that the computer can understand. The other function that the NIC does, it will convert serial incoming data via cable into parallel data for CPU and vice versa. The other function that the NIC performs, it has some memory, or it acts as a buffer or a holding tank. So what you're saying, it has a memory which acts as a holding tank or buffer. It is able to buffer the data so that it can be able to control the data flow. So that is NIC. The other important component of a network is a transmission media. They know we have encountered, even in our definition, we talked about transmission media or even communication media. So we are just also encountering this. And of course, communication is the activity or process of exchanging information in mutual understanding form. So we are saying a communication media or a transmission media is required so that you can be able to connect different computer systems to facilitate information exchange. So we have a diagram here that is simplifying our transmission media, or showing how transmission media are usually grouped. So at the top here, you can see we have the transmission media, and they follow in these two categories. It is either guided or unguided transmission media. Guided, we say there is a physical link between, of course, the sender and the receiver. When you talk about unguided, we can make use of electromagnetic spectrum. So when you look at this diagram, it gives us a clear picture of the different types of transmission media. So we have the transmission media here. It is either guided, this is the wired, or unguided, it is what we call the wireless transmission media. So for the guided transmission media, we have the twisted pair cable, we have the coaxial cable, and we have the fiber optic cable. We'll be talking about these in another topic. We also have unguided, that we can have terrestrial microwave, satellite, and the infrared. So that is a component of a computer network. Another component is a host. So let's just define what is a host. A computer system that is accessed by a user working at a remote location, we can call that a host. So the system can contain the data, and of course the system that contains the data is what you are calling a host, where the computer at which the user sits, it's called the remote terminal. So host is a TCP/IP networking term, meaning any device communicating on the network. So we have talked about a node, any active device on the network. So when you talk about any active device on the network, or even what you are calling a host, we are talking about the same thing. The other important component of a network is segment. Again, a part or a unit of a larger network that is linked by a connectivity device such as a hub or even a bridge is what you are calling a segment. The other important component we can talk about is what is a backbone. And I know we had encountered a backbone, so we'll just talk about it very briefly. This is just a link, and we said it is usually very fast between segments of a network. So the links that is usually between segments of a network is what you are calling a backbone, and we had talked about that. The other one is a network operating system. So remember, previously we have talked about a component, client, and a server. So we said a client usually have a client operating system, and a server usually have a server operating system. So the operating system of the server is what you're calling a network operating system. So basically, network operating system, this is an operating system that does the work of managing a network. So we can say is an operating system that manages network resources, and we can say that essentially an operating system can include special functions for connecting computers and devices into a local area network. So the NOS will be able to do the work of network administration, work of network security and the like, because it is the one that will do the managing of multiple requests or other concurrent access, and it will be able to provide security necessarily in a multi-user environment. So later on, we'll also be looking at the server operating system. This is what you're calling the network operating system, and see, of course, the features that you look out for when you're choosing a network operating system. Of course, security is very easy. We are saying manageability, scalability. Of course, you need to accommodate growth, because a computer network, of course, it's likely to keep on expanding every now and then. So you need an operating system that will be scalable or will be able to accommodate growth, and of course, has management, it is compatible with other platforms and the like. Another important component we can talk about is networking and internetworking devices. So, of course, we can say that expansion within a single network is called network connectivity, and of course, for you to be able to expand a single network, you need a number of networking devices. Again, we'll be talking about all these networking devices like hubs, switches, repeaters, and bridges. We get to know their function, because when you are laying down a network, you need these networking and internetworking devices like switches. You need them to be able to bring the different network nodes together so that they can be able to communicate with one another. You need things like repeaters so that you can be able to amplify signals, or even bridges to be able to filter network traffic and the like. So when we'll be talking about networking and interconnecting devices, that is where we will expound more on those devices. So for the internetworking devices, we can say that expansion that involves and joins two separate networks called internetworking connectivity. So this is an expansion that involves and join two separate networks, and it is what you are calling internetworking connectivity. So you can use all these devices, the routers that help you connect to another network other than your own, among the many others. So again, we will come to that topic. And finally, as an important element or a component of a network, we can talk about network services. So these are the functions provided by the network and are utilized by network clients. So they can include file and print services, database services, and the like. So now that we have seen the different components that make up a network, we can now go to network types and get to see the different types of networks that can exist, because we have said networks come in different shapes, of course, sizes, designs. They come with different capabilities. So I want us to look at the different types of networks that exist. So again, as we look at the different types of networks, of course, it is hoped that we can also be able to approach networks in terms of, when you're looking at a network, you can look at it in terms of capability, maybe the physical arrangement of the devices, and maybe the geographical coverage and the like. So let's look at network types, because you can approach a network from different angles, maybe depending on the geographical coverage, depending on the layout, like the physical layout, like the topologies, and the like. So for the network types, we can look at a type we call a local area network. And of course, a local area network, we can say that it is a network that covers a small geographical area, or we can say a local area network connect devices that are in a small geographical region. So it could be a building, it could be a school, or even a home. Just buildings that are in close proximity, we can call that a local area network, connecting devices of a relatively short distance. So we can go to the other type of network, what we are calling MAN. We abbreviate it as MAN, that is Metropolitan Area Network. So, of course, this network, Metropolitan Area Network, spans a larger area than a local area network. So, it can go beyond what a local area network covers, a network that spans cities and the like. So, we can say a network spanning a physical area larger than a local area network, but smaller than a wide area network, such as a city. So in most cases, a metropolitan area network is typically owned and operated by a single entity, such as a government body or even a large corporation. The other type of network we can look at is what we call a wide area network. So what is a wide area network? Just as the name implies, it covers a wide area. So it can span between continents and the like. So we can say, as the term implies, a wide area network spans a large physical distance. And of course, the internet is the largest one that we know, spanning the earth. So we can say a wide area network is geographically dispersed collection of local area networks. And of course, a network device that we have called a router can be used to connect local area networks to a wide area network. So let's continue with the different types of networks. And the other type of network we can look at is wireless local area network. So we can say these are a network, or this is a local area network that uses high frequency radio waves for communications. So it is able to provide short range connectivity with high speed data transmission. Another type of network we can talk about, personal area network. These are networks organized by individuals for their own personal use. Just as the name suggests, personal is individual for their own personal use. We can have others like storage area networks, or what we abbreviate as SAN, S-E-N, storage area network. So for a storage area network, it can be able to connect servers to data storage devices via fiber optic cables. So like the one we can be able to use for daily backups of organizations. So again, we'll be talking about data backups later on. The other type of networks we can talk about is peer-to-peer network. So you can see we have a diagram here depicting peer-to-peer network. It is showing computers connected to one another. So just as the name suggests, peer-to-peer network, it means when you are peers, no one is superior than the other. Computers address each other as peers. So in this case, in the context of peer-to-peer, it means no one is superior than the other, meaning that these computers are peers. So I want to bring in the concept of course, peer-to-peer network. Of course, it means that these computers address each other as peers. So what do we mean by that? So we can say that computers of a peer-to-peer network can take both a client and a server role. So it means that there is no centralized control over shared resources such as files or printer. So it means that any computer can take up the role of a server or can still take up the role of a client. So it means that any individual machine can share its resources with any other computer on the same network, however and whenever its users choose to do so. So with this peer-to-peer relationship, it means that all computers have equal access and responsibility in the network. So that is why we have said no computer is superior than the other. So let's look at the advantages of this type of networks. That is what we call peer-to-peer networks. Of course, they are easy to install and configure. The other thing, individual machines do not depend on the presence of a dedicated server, simply because we have said, of course, these computers can take both the server and the client role. So we have said that all computers have equal access and responsibility in the network. So we are saying individual machines do not depend on the presence of a dedicated server. The other advantage is that individual users are able to control their own shared resources, simply because each computer is taking up the client and the server role. So when you look at it, of course, it is inexpensive, or rather it is cheap to purchase and even to set up this kind of network. And of course, to expound more still on being cheap, you don't need additional software or hardware beyond a suitable operating system. So of course that has a cost implication. It means that it makes it become cheap. The other thing, advantage, there is no dedicated administrator to be able to run or manage the network. But of course also it works best for a network with fewer users. So now that you have seen the advantages of a peer-to-peer network, let's see the disadvantages of peer-to-peer network. So we have said each computer can take up the server and the client role. So when you look at it from the time, the aspect of security, the aspect of administration, the aspect of sharing resources, you can see also the disadvantages of this kind of network. So for the disadvantages, we can say that the overhead of acting as both server and workstation will affect the performance. So, of course, simply because one computer is acting as a client and a server, this will have an impact on the performance of this network. We are saying it is difficult to share resources. The other disadvantage is the fact that the security relies on each user controlling access to resources to his or her PC, so that you can see security is a challenge. The other disadvantage is administration, because there is no centralized management. So the system is not centralized, making administration difficult. You know, when you have centralized management of the network, administration becomes very easy. So now that we have the advantages and the disadvantages, actually we can be able to derive from what we have talked about the suitability of peer-to-peer networks. So this is just deriving the suitability from what you have talked about. So just understanding in which situations or scenario is peer-to-peer network appropriate. So when, of course, your network is small, peer-to-peer network will be appropriate. If security is not an issue, because we have talked about security, and you can trust individual users to maintain good security, this network will be ideal, because there is no central administrator who will be setting up network policies. It will also be ideal when you feel that it is costly to have an additional computer just acting as a server. When your users can be relied upon to be able to back up their own data. This network will be appropriate. And of course, when your users are close to one another and you don't have plans for expansion of the network, because expansion of the network, or what we call scalability, is important. So if you don't have consideration, or you don't have plans of expanding the network, this network will be suitable. So now that we have talked about peer-to-peer, let's talk about server-based network. Remember, peer-to-peer, we said each computer can take up the role of the server or the client. Now, in server-based, just as the name suggests, there will be the server to take control of the network. So, server-based networks normally provide centralized control over network resources, primarily by enforcing network security and control through the server own configuration and setup. So you can see from this diagram here, we have the server and the different computers, client computers connect to the server. So this is a much more powerful computer serving up or providing the shared resources, and these are the client making requests or accessing the shared resources on the network. So the computer used for servers, you can say they usually incorporate faster CPUs. Of course, they have more memory, they have large disk drives and extra peripherals when you compare them with the end user machines. So in most cases, servers are dedicated to handle network requests from the client. So even if we are talking about server-based networks, and of course I know we talked about servers as a component of a network, later on of course we'll be looking at the different types of servers that can exist in a network, because you can have file servers for controlling the shared files, print servers, database servers, among the many other. We'll be looking at the different types of servers later on. So let's go to advantages of server-based networks. Of course, there is the aspect of sharing of resources. So server-based networks, with server-based networks, you can be able to share resources, you can be able to share printers, scanners, etc. The other advantage of server-based network is performance. So with the server-based network, performance can be optimized to support many clients simultaneously and provide fast response and high data throughput. The other advantage of server-based network is security, because of course we have a network administrator to take care of security, to administer the network, to set network policies and the like. The other advantage of server-based network is administration, ease of administration, because you know that services are centralized and hence making them easier to manage. The other advantage is scalability. So this is ability to accommodate growth. So we are saying that server-based systems are designed to support a wide range of organization sizes. Additional servers are added to be able to increase capabilities, and we have said there are different types of servers that can exist in a network. And the other advantage is on the issue of backup. All the data stored on central storage device, or the data is usually stored on a central storage device, so that it becomes easier to back up data, as you may just have to make schedule and and back up automatically. So let's now go to the disadvantages of server-based network. Of course, cost. You need you need an additional computer to act as a server, and of course it needs to have a suitable server operating system, what we are calling a network operating system, and that add up to the cost. So we are saying it is more expensive in terms of hardware and the network operating system. And of course, in addition, client licenses must be purchased for each machine using the resources. The other disadvantage is on the issue of complexity. You need experienced system administrators so that they can be able to manage the systems. And of course, the other disadvantage, if the server is down, the whole network will be brought to a standstill. So if the server machine crashes, the whole network goes down. So now that you have talked about the advantages, disadvantages, let's see, we can actually be able to derive the suitability of server-based network. In what situations or in what areas is a server-based network suitable? So if in the following situation, server-based network is appropriate. So when there are many users in your organization, you will, of course, server-based network will be appropriate. And of course, if your organization maintains data that needs to be centrally controlled because of centralized administration, server-based network will be appropriate. And of course, if you need a central administrator so that he can be doing network setup, maintenance, of course, setting up policies, server-based network will be appropriate. So now that you have seen different types of networks that exist, and of course that list is not exhaustive, I know we'll be looking at others as we go on, let's look at the importance of computer networks. Of course, when you are deciding to come up with a computer network, of course, there are many comparing reasons why someone will want to invest in a computer network. So, of course, all computer networks, we have said they come in different shapes, of course, sizes. There are those that are big, there are those that are small, and of course, they are usually created so that the users on the network can be able to share resources. So, of course, let's now look at the importance of computer networks. So we are saying that there are some comparing reasons why someone will want to connect computers into a network. So what the network will actually be used for, and of course, it varies depending on the need of the person or the organization who is creating the network. So network can be used for simple tasks, such as sharing files or even a printer, or they can be used for more advanced applications such as electronic point of sales, things like video conferencing and the like. So let's look at some of the reasons why we network computers. So we can just break them down. File sharing. So networking computers will make it very easy for users to be able to share application files on the network. Another importance is hardware sharing. You can be able to share devices. I think we have said about it. You can share printers, disk drives, and the like. The other one is program sharing. So you can share so many applications like spreadsheet, Word. You can run them over the network. The other advantage is user communication. So network allow user to take advantage of communication such as emails, new groups, video conferencing, and the like. And of course, you can be able to do business electronically, or what we call e-commerce, because with this era where the internet user is everywhere, you can be able to do shopping, or you can be able to do business electronically at the comfort of your home. So that summarizes the reasons why an organization need to set up a network. Thank you.
Televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.